All right, welcome back, everybody. Today we're looking at lesson 4, factoring. So just a quick review over factoring quadratics. There's a lot of different types that we looked at, but we're just going to review a few. Okay, so remember when we're factoring 4 terms, so example number 1, we got 1, 2, 3, 4 terms. 4 terms sets itself up nicely to use the box method. So remember, when we are factoring, we're placing the terms inside the box. When you place them on the outside, that's when we're multiplying. Factoring inside. So if you notice, I did the first 2 terms in the top row, and then the last 2 terms in the bottom row. Okay, from there, you look at your top row. Common factor of 7x squared and negative 28x. First of all, with your numbers, 7 would be a common factor, but they also share at least one x in common. So there's your common factor of the top row. So once you know this one, okay, you can figure out the rest of these just by using multiplication. So if I took 7x times x, that gives me my 7x squared. And then 7x times negative 4 would give me my negative 28x. And then lastly, x times negative 8 would give me my negative 8x right here. And then you can always check this last one. If you take negative 8 times negative 4, that does give us positive 32. So we know that's the correct factoring. So factored form is 7x minus 8 times x minus 4. There we have it. So factoring 4 terms, box method. Okay, factoring trinomials is the rest of the examples. Remember, tri is 3 terms, and all of these are based upon standard form. ax squared plus bx plus c. So when we factored these, the first thing we always did is we took a times c. So once we did a times c, we found factors of that would add to that middle one. So in example 2, if there is no a, we assume that a is 1. So go a times c, we'll get negative 50. So we're looking for factors of negative 50. That would add to negative 5. So negative 50 times 1, obviously that does not add to negative 5. So other factors, negative 25 times 2. Those two do not add to negative 5. Other factors, how about negative 10 times 5? Those two do add to negative 5. Okay, so essentially what we do here when we find these factors is we split the middle term using negative 10x and a positive 5x. So now that gives us 4 terms. Well, if you got 4 terms, we can do that just like the example above. I'm going to put my first 2 terms in the top row, last 2 terms in the bottom row, and do it exactly like we just did example number 1. Common factor of my top row here would just be an x. So if that's x, this has got to be x here to get x squared, x times x times negative 10 to get my negative 10x, and then lastly x times positive 5 would give us our 5x. And again, you can check those two, make sure those two multiply out to negative 50, and they do. So x minus 10 times x plus 5. Now, I showed you the box method on this one. Okay, but when a is 1, we don't necessarily have to go through this whole process of using the box method. Once you find your factors of negative 50, which we did, that add to negative 5, notice those two numbers are in my factored form, x minus 10, x plus 5. So when a is 1, you don't have to use the box method. I did show you how to do it on this one, but if a is 1, you don't have to. All you got to do is think of factors of c that add to b, which would have been our negative 10 and positive 5. So x minus 10 times x plus 5. Okay? So box method, don't have to use it if a is 1. If a is something other than 1, like example 3, we do have to use the entire box method here. So let's take a times c, positive 24, factors of positive 24 that add to negative 11. Well, 24 and 1, those two do not add to negative 11. 12 and 2, those two do not add to negative 11. Other factors of 24, how about 8 times 3? Those two add to positive 11. But what if we make them both negative? Negative times a negative, still a positive 24. And then if I add those two, that does give me negative 11. So we're splitting negative 11y into negative 8y minus 3y. There's your negative 11y, and then plus 8. So now we got our 4 terms. We have to use the box method here for this one because a is something other than 1. So I'm going to put the first 2 terms in the top row, last 2 terms in the bottom row. Common factor of my top row here would be just a y, so if that's y, this would have to be 3y to get 3y squared. And then this would have to be negative 8 times y to get my negative 8y. And then lastly, negative 1 times 3y would give me negative 3y. And then you can check these last two. Negative 8 times negative 1 does give me a positive 8. So you know that has to be it. There we have it, factored form. Okay, example 4, a times c. So negative 28. Factors of negative 28. Those two do not add to negative 3, so what about negative 14 times 2? Those two do not add to negative 3. Keep going, other factors of negative 28. How about negative 7 times 4? Those two do add to negative 3. So we want to split our middle term using those two. I want negative 7m, positive 4m, and then minus 7. We got our 4 terms. Plug them into the box. Common factor of my top row would be just an m. So if that's m, this would have to be 4m to get 4m squared, m times negative 7 to get my negative 7m, and lastly 4m times a positive 1 to get my 4m, and if you check those last two, it would multiply to get negative 7. So there we have it, factored form. All right, lastly, number 5. Okay, so remember the first step in factoring that we looked at was you always want to look for a common factor first. If there is a common factor, you're going to have to factor it out eventually. So you might as well do it in the beginning. It makes your problem a little bit easier to factor. So if you look at all 3 terms, they do have a common factor of a 3. So if I factor out my common factor of 3, 3 times 3v squared would give us our 9v squared. And then 3v times a positive 10v, that would give us our 30v. and then 3v times a positive 8, that would give us our 24. So once you factored that out, now if I take a times c, now we're only dealing with 24 versus if we didn't factor this 3 out, if I did 9 times 24, it's a much bigger number that you're going to have to try to find factors of. So it's always easiest if you factor out that common factor first. From here, we're going to see if we can factor this trinomial. So a times c, 24. Factors of 24, then add to 10. Nope, it's not going to do it. Nope, that's not going to do it. 8 times 3, those two add to 11. That's not going to do it. How about 6 times 4? 6 times 4 is 24. Those two do add to 10v. So we got our 3v squared. We would split this middle term into 6v plus 4v. So 6v, 4v, and then plus 8. So common factor of my top row at this point would be a 3, and they also share a v. So if you know that's 3v, this would have to be v to get 3v squared. This one would have to be a positive 2 if I multiply those to get 6v. And then lastly, v times a positive 4 would give us our 4v. And if you check these last two, that does give us positive 8. Okay, so factored form on this one, we've got our common factor that we factored out in the beginning. And then our 3v squared plus 10v plus 8 factors into 3v plus 4 times v plus 2. Now we have it completely factored. So point being here on number 5 is always look for a common factor first. If there is one, make sure you factor that out. It makes your factoring problem a little bit easier. Okay. The other examples we did, there was no common factor on number 4, so we just jumped right to a times c. Same thing on number 3, there was no common factor of all three of these terms, so we just jumped right to using the box method there. Okay, but look for a common factor first, always. Factor it out, it becomes a little bit easier to factor. All right, cool. I will talk to you guys later.